Okay, so creating this video processing ability to work with video in real time instead of in frames. This this is only a small piece of the puzzle, um, but it's a hugely important one. The signal processing ability of the brain is one of the is like the most important thing that makes it so intelligent. Um, and so having good algorithms, having good techniques for doing this is just the base level of being able to um, create a system that can drive a car. Um, and so once you have your visual stuff, your audio stuff, audio processing taken care of, well then then what? Like you have your clean signal, but you still have to uh, process it in an intelligent way. Um, and so I think the best way to think about this is um, in terms of how the brain does based on my experience and reading about how it works and whatnot. Um, is once you have this clean signal, you basically um, have to run it through. You run it through a hash function, and that gives you a lookup so that you can instantly look up a piece of information that you need. And so this is sort of like the core function of memory. Of course, it's described in sort of computer terms, but um, I think this is like sort of the key thing to make sort of a real-time system work. Is you have this signal processing where you're processing um, where you're processing the signal, but then you need to uh, signal. Right, the hash. So as an example, like I look at your face and I recognize that's you from like a signal processing point of view. You have the visual um, coming in, and it's recognizing, it's able to sort of hash the information that's in the vision, and then able to instantly recall that it's a person that it's looking at, and that's happening sort of maybe on one core, right? The core for like just recognizing basic objects, and maybe on another core you have like um, another sort of hash function where you're taking the features of the face and like, okay, boom, that is and I know this is so and so's face that's associated with this person, but you can see here how it gets so confusing because like to take the features of the face and associate them with a person, but then also associate that I'm looking at a person are like two computations that they're based on the same data, and so it's like the parallelness is so much more than just computing the two things separately, right? It's so much more interconnected. Um, so how would you build a machine that could do something like that? Make those kind of computations. And of course, this is where like analog computing helps. If you try to think about that task, and instead of like a piece of software that has to run, think about it as an effects chain that's running on a piece of audio, and suddenly the problem seems a little bit more simpler in a weird way. Like your signal comes into your object recognition box, and I take out some signal out of that, and that goes into my feature detection, and that part of that goes into my face recognition, remembering people, and part of that goes into my learning new faces, and it all is just sort of, you know, everything's just plugged into everything else and just wired into this big jumbled up mess. And uh, and so to think about having this big wired jumbled up mess, but you're not doing it with one audio signal, you're doing it with millions of them, right? Like how many neurons and stuff you have. It's sending information from all my extremities and everywhere else, my eyes, my ears, and sending all this information in. Doing this sophisticated processing and filtering within this parallel processing and filtering as well. And what's interesting about thinking about making an AI in this way is that it more directly correlates with how we know that the brain works. And we think about the brain rewiring itself, um, and learning new things. And you could think about, rewiring your audio effects to create um, to create different um, to create different sounds and whatnot. Um, and using the same techniques to create our AI. So, and what's extremely frustrating is that signal processing in particular is like very secretive and obtuse in how to actually do it. Like, there really isn't an open source community in the same way that there is in other areas of science with digital signal processing. Everything is so much more secretive, and um, once you find your cool little solution, you make it into like a $300 plugin that you go and sell. And but no one realizes like the usefulness, like this knowledge and stuff they're creating can be used for so much more than just audio. And that's the case in everything on the computer. Like, going to be the biggest hurdle in being able to build a system that can do anything intelligent is overcoming this need for secrecy around software. Um, it's very frustrating, like even just trying to build prototypes of things. It's like, okay, well, I've heard of this scientific thing here that's possible. I've heard of this thing here that's possible. So why can't I just whip something together, like combine this and this, and make something cool? And like every time I try to do it, everything's just so closed down and locked down. Well, I got to pay a subscription for this. I got to, um, I can use your code, but I can't see how it works, so I can't modify it and make it any better. If I want to change it and make it better, I have to write other code that like interacts with it in like a weird kludgy way, and you can't actually innovate and get anything done. Like, yes, it takes a high amount of intelligence to be able to come up with some cool invention or cool discovery, but there is no way that you're intelligent enough to um, be able to know every single possible way that something can be used. And of course, this is always used as a boogeyman for why you need to keep secrets, but it's also why it helps not to, because like you just like you could be sitting on a piece of software that could save the world, but you don't want to do that because you think you're so clever that the only possible use for that piece of software is to exploit people for some money or whatever. And that's how clever you are. But like you can't be that smart. You can't know that that's the only way that you could use a piece of software. Um, and this is especially like apparent in the magic community as well. Like everyone is just so secretive with all these little techniques for which is which essentially boiled down to like how to move something in some silly way, or like a neat little mechanical device, and they won't tell you how it's done, because these magicians, they're so much smarter than you, that they know that their little thing that they've invented can only be used to deceive you for entertainment purposes. There is no other way that that discovery that they've made could be used to help anybody, because they know better. And so they have to keep it a secret. I just. And all of science is like this. It is so frustrating. You cannot get anything done. There's no way you're that smart. Anybody. Everyone is sitting on all these cool things that could like help people and save them, but they're like, no, 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 no. The only way that I can, the only way I'm giving you this secret for how this cool little mechanical thing works that you could probably spend an afternoon figuring out how it works anyway is you gotta pay me money. And like, oh man. And like in the digital signal processing world, um, nobody shares their code. They'll share a white paper, but like, and they'll go through and describe everything about how they do something, and then they'll give you a formula for how to describe what they've done, but then to implement the formula it requires like pages and pages of code, because formulas, they look small on paper, but they're really just like compressed information. They're really an algorithm. And so to actually implement it on a computer requires a lot, like pages and pages of code, and then there's all these other subtle things with computer science and other things you need to know in order to implement it. And and so in all of science, these people are like giving off this impression that they're sharing these scientific achievements, but they're not. They're just looking for praise. Like if you want to share it, you share your code, so I can just build something better on top of it. That's what science is building on top of other people's work. It's not sharing and hogging stuff for yourself. Um,